morning or good afternoon, depending on when you are watching this video. Welcome to math class. We're starting here today with Unit 2. So we just took tests on Unit 1 last week, finished that up, or today, or yesterday, I guess, whenever. And took a little bit of time off. Now we're going to start on Unit 2 here, and we are in section 2.1. So I want to make sure you get 2.1 into your table of contents. If you want to write a little tab with Unit 2, a little sticky note, now would be a good time to set that up. Go ahead and pause the video and do that. We are talking about solving one-step equations, and today is October 26th. So go ahead and take care of that. Pause the video if you need to get your notes ready, geared up. You should have just finished up your quick write for the day. So yeah, let's get going. So, and again, the slides are always in Spanish if you know. So solving one-step equations. What is a one-step equation? Where do you start? Where do you end? How do you know? These are some of the questions we're going to be asking today throughout this lesson. The goal is to move to multi-step equations by the end of this section and just generally become better and more fluent at solving equations in general. So we're going to address some questions in this video that we'll use throughout the whole chapter. So key vocab. Let's talk about some things that we need to know. This is in your vocabulary sheet that we did, so we're going to review some things. An equation would be two sets of values set equal to each other. So we have two things that are set equal to each other. There has to be an equal sign. We'll talk about that in a moment. Out there, I just gave up on this word. Apologize for that. Take a second to write this in. I'm going to keep going at any point. If you need to pause during the end puzzle, I'll probably put a pause for you to write stuff down. A variable is any letter used to represent an unknown value. Value is just another word for number. Operation, which we will talk about. The main ones are plus, minus, multiply, or divide. You should know the operations. We'll eventually get into exponents and square roots, but we'll talk about these two later. An inverse operation, we're going to spend a couple minutes talking about that, so I'm not going to describe it yet. But I will say it undoes operations. Sorry about my computer loading. Can't help it. Let's see if I can mute it. There we go. Alright, so this is some vocab. So again, hopefully you've paused the video or right about now. Alright, so first and foremost, we're talking about equations. Equations have to have an equal sign. If they don't have an equal sign, they are just an expression. So you have to have a set of values, right? So 4x to 3x set equal to another set of values. So it means that whatever this is in total needs to be the same as this in total. And essentially in solving the equation, we're going to say what number could go in here for x to make each side equal to the other one. Okay, so again, don't know what's going on. That's what I'm looking for. Name. That's just happened. Oh my goodness. There we go. Sorry. Again, no equal sign makes it an expression. And that's important to know. If you're not dealing with an equal sign, you're not dealing with what we're talking about today. So make sure that when you have an equation, there is an equal sign. Again, make sure this gets in your notes, but that's the first thing. Right, it's the big number one. So in your notes, I'd write down number one, equations have an equal sign. This is a good example of an equation, so you can write that down as well. So here are some examples. We have 2x equals to 6. So the question is, what does this need to be for this? It equals to this. Same thing, 7 minus x equals 10. X plus 2 equals 8. X divided by 5 equals 2. 2x plus 2 plus x equals 3. And I do want to make sure that we're clear. It can be the opposite. 6 equals 2x. It doesn't matter what side x is on. 7 equals 4 minus x. I don't know. It doesn't matter. X can be on either side. So I'll write that down as the notes. Can be on either side. Awesome. So there we go. So the second thing we have, is to know, to start, you need to know where to end. What does that mean? The goal when solving one-step equations, or any equations, you're trying to get the value of the variable. We want to know what x needs to equal so that each side is equal to the other. In other words, a variable alone set equal to some number. So this is our ultimate goal. X equals 2, 2 equals x, or whatever our variable. We want the variable set equal to one number. So the variable set equal to some number, and I guess the variable alone. Okay, that's our goal. So we need to start with that idea. How do we get just this x by itself? So that would be our goal. So again, take a minute to write down some notes. Pause the video, write it down, and we'll move on. So to begin, we know we're trying to get the variable by itself, right? You got to identify your variable. I don't know what word I was looking for. You got to find your variable and start by removing things until it's all alone. Okay, you're going to have variables in your equation. And the goal is to just start stripping things away until it's all alone. Variable, all alone. Okay? So step number 3, find your variable, start removing things until it's all alone. So you might be asking yourself, how do we do that? To do that, you have to understand inverse operations. What are inverse operations? Glad you asked, because we're going to talk about that for a couple minutes. And if you're in everyday algebra and also watching this video, you already spent some time doing this. This should be a refresher just to check your memory. Make sure you've got what we talked about in our last video. Inverse operations do the opposite to their complementary operations, right? So complementary are things that go together. PB and J are complementary. Bacon and everything would be complementary. That's just me. I haven't had bacon for dinner, and I think it's delicious. But things that go together. So, for example, in math, plus and minus are a team. We talk about them often. Okay, plus and minus are a team. Divide and multiply are a team. But because they are a team, they also are opposite. They're kind of like opposites attract type of thing, if that makes sense. So if you have a plus, to get rid of it, you do a minus. If you have a minus, to get rid of it, you do a plus. They are opposites. Our inverse operations is also, they are complementary. They go together, but they also invert, or, let's write it down. They undo each other. Think about like a computer, like when you make a mistake and you want to undo things. That's what inverse operations are. They undo their complements. Okay, so to undo a divide, you multiply by the same thing. To undo a multiply, you divide. So I would say this is what you want to write in your notes. Complementary operations are inverse operations and they undo each other. And then make note of what the complementary and inverse operations are, right? Plus goes with minus, divide goes with multiply. All right. So how do you use the inverse operations? They are used to remove an operation. They are used to balance an equation. Okay? So if we have the expression x plus 3 on one side set equal to 6, so now we have an equation because it's equal. How can you get rid of this plus 3 to leave the x alone? Because remember, the goal is to get x by itself. We're going to start removing things. This is kind of in its way. We want x alone. So how do we get rid of a plus 3? Well, it's plus. So what's the inverse of plus? You guessed it, minus. If we have a plus 3, we're going to do a minus 3. It does not make sense if we have a plus 3, don't do minus 4. All right, like that's a little like side note, right? I have to write this down. I just want to make sure we're clear. If you have a plus 3, don't do a minus 4. If you have a plus 3, do a minus 3. You want to get rid of it, right? And then we have to remember that if we do something, we have to balance an equation, right? If we do a minus 3 over here, that's great. We'll do some stuff, but we also have to do it to the other side. That's been talked about many times. You should know that by now. In the equation, let's see if we can write it down. Side note, in an equation, what is done to one side must, not like should, not like it'd be nice if we did, it has to be done, must be done to the other. In this case, if we do a minus 3 over here on the left side, we got to do it to the right side. So this is one way of writing it. I don't like it that much because it's ugly to me. So if I had the expression here, I put a little minus 3 and draw a giant 0 here so he knows it goes away. If you've had me in class before, it would have looked something like this, just get rid of it. That leaves you with 0, which would then bring the x down by itself. Then you can do the basic math operation. 6 minus 3 is 3. Now we have x equal to 3. The question is, did we end up with what we wanted? X alone set equal to a value. Yes, we did. We're going to give it a nice, beautiful check mark. Alright, we're good to go. So that's an example of how to use the inverse operation. Again, take a moment, pause, write stuff down. I was doing some actual pausing in videos, and I just assumed you just get distracted. So I'm going to ask you to pause your video and get going. We only got a few more slides left, and we'll do some examples, and then we'll go from here. So let's go back here. We have another example. Now, we should be able to identify the variable. There it is. And this 4. The question is, what operation is this? No question should pop up, or have popped up. What operation is this? This is multiply. Multiply. Okay? Which means we now have to undo multiplication. Okay? This time we're using the inverse of multiplication. So this is multiply. So how do we undo multiply? Well, the inverse of multiply 4, which is multiply 4, is divide by 4. So again, we take what we see. We want to get the x alone. We got to get rid of this 4. Well, what is this 4 doing to x? It's multiplying by 4. So to undo what it's doing to x, we're going to divide by 4. Divide is this little line. You divide by 4 here. Rule follows. It is an equation. We see an equal sign. So if we do divide by 4 on one side, we got to do divide by 4 on the other. You can read over here. That turns it into a 1x, but we don't write the 1 because we're lazy, so it just leaves us with x. Then we can do 12 divided by 4, leaving us with 3, and there we go. Again, did we end up with what we wanted to, which is a variable set equal to a value? Yes, we did. Give that a giant check mark. And there we go. That's it. These are called one-step equations because it takes one step to get to where we want it to. Okay, so these are like intro to solving equations. Do one thing, and you should generally finish the equation. And then next class, we're going to figure out how do we know if we did the right thing. And we'll get to that later. But for now, solving one-step equation. All right, would be fairly straightforward. So let's summarize. This would be a good time to pause if you need to write something down. In a one-step equation, we have to remove whatever is around our variable by performing the inverse operation. And I will say one step. I know it's already written right here that says one step, but it's like we only have to do one thing. They're called one-step equations. You shouldn't have to identify that they're one-step equations, but we practice one-step equations. There's nothing about knowing that it's one step, but just know that right now it's one step. We must make sure that if we do something to one side of the equation, we do the same to the other side. It's like a holy rule of mathematics. So this is crucial. I know we've talked about it for a long time, so please write it in your notes. Being a little kid right with the star. I'm trying to give you some time to write it down in your notes, but there we go. And then variable set equal to a value. That's our goal. Okay, if we've done that, if we have one variable set equal to one value, one variable set equal to a value, we are done. And again, next class we'll learn to see how to see if we've done it correctly. So what I want to do now is just do a couple practice problems with you. And then once you're done with this video and you've answered all the questions, you'll move into a worksheet with a bunch of one-step equations. It'll be 15, maybe 10. I don't know. I'm going to do it right now after I make this video. Just be lucky the Blazers are losing by about 30 because I probably wouldn't have done this video because it would have been a good game, but I stopped early to do my job. I would have just gotten up early tomorrow. But anyways, we're doing this video and we're working on the worksheet that you'll see in Google Classroom after this. Okay, so a couple practice problems. So here we go. We got our first problem here. We have 2 plus x is equal to 10. Now, we have to identify the variable. We have to know what's happening. It looks like we're adding to our variable. Now, this is kind of tricky because it's off to the side. Okay, and we'll talk about what that looks like with like trickier situations. But we're going to do that. So it looks like we want to get rid of this plus 2 over here. So if we want to do that, figure out what we want to do. We want to get rid of that. So we want to get rid of this by taking away 2. Again, if we do it to one side, we've got to do it to the other. Check our answer. 10 minus 2 is 8. 2 minus 2 is 0. So we have x equals 8. Now, that's easy because it's plus x, so that's x equals 8. One variable, one value, we're done. Okay, so let's go over to the next problem. We have 5 set equal to -7 plus x equals 5. So again, I've identified my variable over here. I know I got a plus and a -7 over here. This is one of those unique situations. We see plus, but that's not what we're going to undo. We're not undoing this plus, all right, like that. We're undoing this -7 or -7. So you should know to undo a -7, I'm going to add 7. That's going to leave us with 0. If you do it to one side, you've got to do it to the other. That's going to equal 12. We got our equal plus x. We can get rid of the plus 0, so x should equal 12. We have one variable set to one value, which is 12. So that means we're good to go. Alright, next one, we have -2x equals 12. I have my variable here. I got to figure out what operation is here. It's right next to it. There's no operation. Usually, if there's no operation symbol, we can assume it's multiply because we know in math, if numbers are just next to each other, we're going to probably multiply them. So we got to undo this multiplication. We do that by dividing. This is a divide line. I'll write that down for those of you that just don't seem to remember that thing. Divide line. Okay, now I'm going to divide. Question is, do I just divide by 2? Hopefully, you want to get rid of all of it. You don't want to just get rid of the 2, you want to get rid of the -2. Now we can box that all up. Now it's going to equal x down here. If I divide again by -2, 12 divided by -2 is 6, but when we have one value is positive and one value is negative, our answer comes out to negative. So x equals -6. Alright, so this is one of the more unique ones that we'll be talking about in this class. But if we follow the rules that we've been talking about, we should be able to make sense of this. Let's see. Find a different color. I'm going to go with an orangey color. There we go. Alright. So, we're over over here, x over 5 equals 3. Now, I have my variable. I got to figure out what this operation is. Well, if I look over here, that's the divide line. Well, I just need to know that I just got to undo divide. I use its inverse to do that. So I'm going to multiply this whole thing by 5. And in reality, we're going to multiply it by 5 over 1, because any number can be written over 1. And doing that, we create this like diagonal giant 1 that makes the 5 and 5 go away, and we get left with x over 1. See how there's like that little 1 over here and x on top? The line just doesn't go away. Well, again, we should know by now that we don't have to really write the over 1, so we can get rid of it. And again, if we do it to one side, we got to do it to the other, and what we did was we multiplied. So we just have 3 times 5, which you should know is 15. And here we go with our answer. One variable set to one value. So these are one-step equations. I don't want to get too crazy into describing them or do anything like that, but that's all there is to it. Find the operation that is affecting x and undo it. It's getting multiplied, divide, it's dividing, multiply, it's getting added to, subtract, it's being subtracted from, add. Undo what's around x so that it stands alone. Do it to the other side so you keep it balanced, and you should be good to go. When I come back, we'll probably spend a little time writing down kind of like rules, but it's more important with multi-step equation, not just one step. You're just doing one thing. So there you go. I'll repeat it. So if you want to write it down, identify the variable. Write it down. 1. Identify variable. Find what is being done to it. 3. Undo that thing. 4. Do it to the other side. To keep the balance. 5. Done. Alright, take a second to try to figure out what I wrote there. Good luck. Write it in your notes, and when you're done with the video, go ahead and check out the worksheet and try to practice a little bit. And I will see you